Hello everyone, this is Mr. Appel, and today I'm going to show you how to do a problem like number 4C in the word problems practice from section 2.7. So here we go. A lot of words there, so I'm going to try to sift through it and see what's important. She's designing a storage container to hold feed. I see cylinder up here. It's a cylindrical design, so I've got the formulas there. The horse eats up to 40 cubic inches. That's a volume, I'm thinking. And she wants her container to hold that much. So we want our volume to be 40. So that tells me right now I'm going to use my volume formula and put in 40 for the volume. So I'm going to write that right now and then keep reading. The material she's using is expensive, so she wants to use as little as possible. As little as possible. That sounds like a minimum. So I'm going to be writing some function. I want as little as possible, so a minimum. And we're talking about the material to make it. So that's sounding like surface area. So I want to write a function for surface area that is minimized. I'm going to try to find a minimum value there. Okay. So, like we've seen in some of these other problems where there's an extra variable, I'm going to solve this one for h, so that I'm going to divide both sides by pi r squared. So I've got 40 over pi r squared for h. Now I'm going to write my function for surface area, and I'm going to replace the h with this so that I'll only have one variable. So I've got 2 pi r squared plus 2 pi r h. But now I'm replacing h, I'm substituting pi r squared in there. I'm going to simplify this a little bit just to make it a little bit easier, to type into my calculator. I can cancel out that pi, cancel one r with one of these r's, and so what I'm left with is 2 pi r squared plus, and don't forget about that 2, so that's 80 over r. And honestly, you can put either expression into your calculator, either function in. They are equivalent to each other. I just find this version a little bit easier to type into my calculator. So let's go ahead and do that now. So I'm going to put that in my y equals. So that's 2 pi times the radius squared. So that's x squared. I'm not sure why I put that in parentheses. That really wasn't necessary. But doesn't hurt anything, plus 80 over x. Again, we're using x in place of r, just because your graphing calculator doesn't know any better. All right, so now I'm going to try to find the minimum value of that function. And I see an x in the denominator, so I'm thinking this is going to be rational. So it's going to be really important to choose a good window. So my radius for my window should be positive numbers, so from 0 to not really sure what, so maybe I'll try out to 10. That's just kind of a guess. My y values, this is surface area. Not really sure what that's going to look like. Maybe I'm going to guess something like 1,000 going up by 100. And again, I'm making a guess just like you would here as to what that might look like. And let's graph that and see if that's any good. All right, well, we got a good picture of our graph. I can see down here somewhere there should be a minimum. If you like to zoom in a little bit, you can do that. It's not necessary for this calculation, so I'm not going to bother. So I'm going to do second calc. I want to calc a local minimum, so that's 3. So I'm going to press 3. I'm going to do my left bound. So I'm just going to arrow over. That's really annoying that the words left bound are blocking my view there, so I have to go a little extra far just to make sure I go past it. Wow, that's kind of annoying. I can't really see where it is. Oh, there it is. I can kind of see it poking out there. So I'm making sure I go well to the left of where I think that minimum is. Press enter. And now I'm going to go well to the right. And press enter again, and then a guess. Really kind of tricky to guess there. And this is where choosing a better scale might be okay, but You don't have to be perfect, so I'm going to press enter there, and I get my guess, and I see my guess there is at, it looks like 1.853 about. So my radius is about 1.853 inches. Wow, that does not look like a 3 at all, and I know you'll yell at me if I don't fix it, so I'm going to fix it. 1.853 inches. And that's the radius. The question also asked for the height, so you do need to take that radius, plug it back in over here to find the height. Be sure to follow order of operations. Remember, with your calculator, if you want that entire denominator to be divided into 40, got to put that in parentheses. And if you do that, you should end up with a height of 3.708 inches. And those are the dimensions that satisfy this problem. I hope this was helpful. Thanks. Bye-bye.